Hey folks, this is Kevin Jones here to talk to you just a little bit more about the little man computer. In the last lesson, you learned all about the structure of that sort of hypothetical device and how it operates, and hopefully you got a feel for how this thing could potentially be used to build, well, at this point simple, but eventually more complex computer programs. I want to take a couple minutes now just to look a little more closely at the instructions of the little man computer and kind of highlight a couple of features of those instructions that are going to be important to this class. So the first is talking about, let's see, make sure I got my pen. Okay, cool. Something called an opcode and an operand. Okay, so opcode, opcode is short for operation code. And I'll see if I can write this a little more clearly. The idea of an operation code is it's the numeral, the number that uniquely identifies each instruction. So you probably already identified while you're looking at these instructions that a 1 in this first position here uniquely identifies whatever instruction is in that mailbox as the add instruction. So in the case of like a 115, then the opcode is going to be in this first bit position here. This means to add, and what comes next in this instruction is something called the operand. Operand is just a term that refers to the numbers that follow in an instruction that can help specify what to do with it. So in this case, the add instruction, which is indicated by this 1 in this first position here. The add instruction is defined to be to add to the accumulator or to add to the calculator whatever memory contents are stored in the mailbox whose number follows that first position. So this says effectively add to the accumulator the value that's in mailbox 15. So you can see these two terms a lot as we progress through this course. The opcode that uniquely specifies each instruction. When we talk about operands, these are the things that that instruction uses to complete its execution. In the case of these first 8 instructions, you can see that we have each of these requires 1 operand, and each one effectively specifies a mailbox, or the meaning's slightly different, right? In the case of the add instruction, we're going to take the contents of mailbox 15 and add it to the accumulator. But if we saw something and said like 845, okay, 8's my branch instruction, and what this means is, if the result in the accumulator is positive, then don't just get the contents of mailbox 45 and put it in the accumulator. We're not adding it, but we're going to assume that that's our next instruction. So this is still referring to a mailbox, but it's because the instruction is kind of different. We're doing something slightly different with that operand. So each of these have 1 operand, and you might notice also that these 3 instructions down here don't have these X's. There's not anything really we specify when we issue these instructions to the little man computer. So these are instructions that have effectively 0 operands. When we issue an input or an output or a halt instruction, we don't have to specify a mailbox. We don't have to specify a data value, anything like that. So, the little man computer you can already see has instructions that have different numbers of operands, and in fact that's true of effectively every computer. The instructions, which are uniquely identified by this opcode, have different numbers of instructions, as little as 0, and some computers have instructions that have 4, 5, or 6 operands. Okay. The other thing I want to point out, let's see if I can switch colors real quick. Oh, cool. Is the fact that of these, what is this, like 10 or so instructions, we can sort of group them into 3 broad categories by sort of what their function is. That can help us kind of conceptualize these instructions. And in fact, we'll use these categories multiple times throughout the course. So the first category is here. Add and subtract are what we're going to call our operate instructions. And so these are instructions that actually operate on data. They perform some type of arithmetic or logical operation on data, which include addition, subtraction, logical and, logical or, negation, stuff like that. The next category are what we might call our data movement. Actually, I'll use a different color for this, so kind of really bring this out. Okay, are called data movement. So these instructions typically don't operate on any data. They don't do anything to a piece of data, but they do move it around the computer. So you can see that the two instructions here, store and load, these are, of course, moving data from the mailboxes to the accumulator or back. You can also consider our input and output instructions to be data movement because these two are moving information either from the input to or from the inbox to our accumulator or from the accumulator to our outbox. And then the last category, I'll use blue here, are our two branch instructions and our halt instruction. And what we'll do is we'll call these our control instructions. So these are instructions that change or alter the function of our computer. They sort of control how our computer operates. So, I just realized I missed one of my branch instructions. Let me try to redraw that. So the branch instructions clearly are changing the control flow in our little man computer. And of course, the halt instruction, will bring the little man to a stop. We'll cease all further processing. So those four instructions we're going to call control instructions. And these three categories: operate, or sometimes these are called arithmetic and logic instructions, data movement instructions, and control instructions, sort of form the three broad groups through which we can sort of view all of the instructions available to us in not just this computer, but in some of the other computers that we'll look at further on in the course. Okay, that's all I got. I'll see you next time.